Hey there guys, in this video we're going to cover chapter 1.6 part 1 notes, which is angles of elevation and depression as well as arc length. We're going to start with angles of elevation and depression though. So angles of elevation and depression refers to kind of how we're measuring angles depending on an observer's point of view. Now typically this was used to measure things like trees or lighthouses or things that are very far away that aren't very easily measured, but using angles of elevation and depression, you can kind of approximate. So first off, when we refer to angle of elevation, this is the angle between the horizontal and the observer's line of sight to the objects when the observer is looking upwards. Ergo, you will have a horizontal line, which is the observer's kind of point of view. Angle of elevation means you're looking upwards towards the object. Where angles of depression, you are looking downwards towards the object. So here's another example. We have our observer here. If we're looking up towards an airplane, then this is an angle of elevation. If we are looking down towards a boat, then this is an angle of depression. Now let's try some practice problems. So the angle of elevation to a nearby tree from a point on the ground is measured to be 74 degrees. How tall is the tree if the point on the ground is 28 feet from the tree? And then we have to round our answers to the nearest tenth of a foot if necessary. Our first step is to draw this diagram. So let's assume this is my tree. And I know that I am 28 feet from that tree. So I know that length. And I need to find the height of the tree, so I don't know this. They also tell me the angle of elevation from the point of the ground is measured to be 74 degrees. So my angle of elevation is this. From the ground upwards looking to the tree. So it's the line for the ground upwards to the line that connects to the tree. So this is my angle of elevation, and then this would be my 90-degree angle. Now, I cannot use Pythagorean theorem since I do not know 3 sides of my angles or 2 of the 3. However, I can use SOHCAHTOA because I have an angle as well as a side length. Now, from this angle, X is considered opposite, and the 28 will be considered my adjacent. So OA will be the TOA, or tangent. So we will be using, don't forget, SOHCAHTOA. We're using TOA, where we are using opposite and adjacent. So we're going to be tangent of the 74 degrees is equal to the ratio of the opposite, which is X, over my adjacent, which is the 28. From here, to get X by itself, I'm just going to multiply by 28 on both sides. That will give me X equals 28 tangent 74, which in this case, it will give me X is 91.583, so and so, but I had to round my answer to the nearest tenth, so it is 91.6 feet. So this is my answer. So all you're really doing for angles of elevation and depression, they're just word problems, and you have to draw the diagram and then solve, rather than just being given the diagram. So let's do another practice problem. So from the observation deck of a skyscraper, Hunter measures a 45-degree angle of depression to a ship to the harbor below. If the observation deck is 934 feet high, what is the horizontal distance from the base of the skyscraper out to the ship? So in this case, it's going to be a slightly different diagram. So we know that he is looking at the observation deck of a skyscraper. So I'm going to draw my skyscraper here. Next, I know that I am looking at a 45-degree angle to a ship in the harbor below. So I'm going to have a ship down here. Now, remember that for angles and elevation and depression, they kind of reference a horizontal, or the horizontal line that is kind of the observer's point of view. So my observer is up here at the skyscraper. So my angle of depression is looking downwards from this horizontal. So this right here is my angle of depression, not this angle in here, this angle here. Now I can keep drawing. I can connect these. I know a few more things. I know that the observation deck is 934 feet high. So I know the height of this skyscraper. What I want to find out is what is the horizontal distance from the base of the skyscraper, so from the bottom, all the way out to the ship. Now, notice this 45-degree angle is outside of my triangle. That's fine. There's a few things you can do. First off, this horizontal line is perpendicular to kind of this vertical line here. So we know these two angles have to equal 90 degrees. So you can just figure out what this angle is by doing 90 minus 45. We can also use the transitive property, which tells me that this angle and this angle will be congruent. So don't forget the transitive property, which tells me if I have two parallel lines, then kind of my opposite interior angles will be congruent. So these will be congruent, and these will be congruent. So these kind of side ones. So same thing, here's my parallel lines. This 45 will be congruent here. If that didn't make sense, once again, this will always create a 90-degree angle, the horizontal line and your vertical. So if I had done 90 minus 45, you would end up with, luckily for us, we still end up with 45. Because 45 plus 45 will give you 90. So either way, you still get the answer. It won't always be 45 for both of them. Remember, all sum of triangle angles need to be 180. 90 plus 45 plus 45 is 180. This is a lucky case, but whichever is the case, you can either use transversal angle properties to use the angle of depression to find the one inside the triangle, or just use complementary angles, which tells me the sum of two angles will be 90 degrees if they create a 90-degree angle. But either way, you can use either 45. Most people get confused with the transitive property, so let's say I'm just going to use that 45 that I found here. Well, in this case, I have an opposite x and adjacent 934. So this is going to be tangent again. So I'm going to do tangent of my 45-degree angle is opposite over adjacent. So my opposite is A and my adjacent is 934. X will be 934 tangent 45, because I'll multiply both sides by 934 to cancel it out, which will leave me with x is approximately 934 feet. If you had used this 45, that would have been fine, except this 45 down here would have given you an opposite of 934 and a adjacent of x. So you still do opposite of adjacent, except your numbers would kind of be switched, which is fine. We still get the same answer though. But that's this problem. If you're still confused about this, that's fine. We'll go do more examples in class. But now let's move on to arc length. Arc length, luckily, it's easier. It's generally a formula that you need to plug in. The arc length is the distance around an arc. So we have a sector and we want to figure out the circumference or the outer distance around my arc. Now the formula is just the circumference multiplied by the ratio of the center. So we know the formula for a circumference of a circle, which is 2 pi r, so that's where this comes from. And then we multiply by the ratio of the circle we are talking about, so the sector of the circle. So in this case, if we have 72 degrees for my central angle, then you'll just do my angle is 72 degrees divided by 360, which is the total amount of degrees in a circle, times the formula for a circumference of a circle, which is 2 pi r. In this case, my radius is 2, or my radius is 4. So you do 2 pi times that 4. But let's do an example. So we have a circle S with the measurements of RST, so RST to be 98. So this is 98 degrees. We want to find the length of the arc. We're also told that RS is 4 units. So we know the radius. Now we have to find the arc length. So we want to find this distance here. So if I use my formula, it is going to be It doesn't really matter if you put alpha on top, the angle in front. I prefer to do it like this, where it's the ratio of my angle to the total summation angle of a circle times the circumference of your circle. But in your formula chart, it will look like this. Either way, you still get the same answer. It's still the same formula. But in this case, my angle is 98 degrees divided by 360 times 2 pi times my radius, which is 4. If you put this into your calculator, you will get 6.84. And that's all you have to do. So it's just identifying different parts and plugging them into a formula. Same thing here. This time they tell me I have an angle of 30 degrees and GH, or my radius, is 5 degrees. So it's going to still be my angle divided by 360 times the circumference of a circle, 2 pi r. I know my angle is 30, and I know my radius is 5. If you put this into a calculator, you'll get 2.62. Delta Math has a calculator that you can use. You can also go to Desmos.com, which has a free online calculator. So I would suggest using those, not necessarily a phone calculator to do these type of calculations. But we'll finish the rest of the notes in class. If you have any questions, feel free to email me or send me a message on Remind. Otherwise, have a nice day.